The Baltic Sea's dead zone spans an astonishing 70,000 square kilometers. That's larger than the entire country of Denmark. In these lifeless depths, oxygen levels plummet so dramatically that most marine life cannot survive. It's a foreboding glimpse into a growing environmental crisis affecting oceans worldwide. Why has the Baltic Sea transformed from a lively ecosystem into a suffocating expanse? This is not just a regional disaster. It's a global emergency unfolding in silence, with over 700 dead zones worldwide. What unseen forces are we ignoring that propel this invisible catastrophe into a growing threat? In this journey, discover how agricultural fertilizer runoff, untreated sewage, and climate change converge to create the Baltic Sea's dead zone, where almost no life survives. With over 7 dead zones globally, this hidden crisis is escalating. Explore potential solutions like North Sea inflows, their successes and limitations, to combat this environmental catastrophe. The Baltic Sea, encircled by 9 countries, was historically a vital marine ecosystem teeming with life. Its semi-enclosed shape, however, makes it highly susceptible to accumulating pollution. This geographic quirk contributes to its current plight, a massive dead zone where oxygen levels have plummeted. Agricultural runoffs from countries like Poland and Germany, combined with untreated urban sewage, dump excessive nutrients into the sea. These nutrients trigger perilous algal blooms, exhausting the oxygen. Once a thriving habitat, the Baltic Sea now exemplifies the stark consequences of human-induced environmental stress. With a population exceeding 85 million, those residing around the Baltic Sea are deeply reliant on its bounty for jobs, cultural identity, and sustenance. Unfortunately, the ever-growing dead zone jeopardizes all these prospects, threatening the regional fishing industry, worth over €2 billion, and imperiling food security. The potential loss of biodiversity is alarming, as species that once thrived, like the cod and herring, struggle to survive in the depleted waters. Moreover, tourism, a vital economic contributor, faces declines as beaches become plagued by algae. This is not just a regional problem, it's a warning for global marine health. Eutrophication is the silent culprit behind the expanding Baltic Sea dead zone. When excess nutrients, especially nitrogen and phosphorus, enter the water from agricultural runoff and untreated sewage, they trigger massive algal blooms. These blooms deplete oxygen as they die and decompose, rendering vast areas inhospitable to marine life. In fact, the Baltic Sea now hosts one of the world's largest dead zones, stretching over 70,000 square kilometers. Despite efforts to curb nutrient pollution, climate change compounds the problem by warming the waters. This reduces oxygen solubility, exacerbating the oxygen crisis and accelerating the spread of these aquatic wastelands. Agricultural runoff is a significant contributor to the suffocating conditions in the Baltic Sea. Each year, farms in the surrounding countries use approximately 1.2 million metric tons of nitrogen and 30,000 metric tons of phosphorus on their fields. These nutrients are essential for crops, but when it rains, a considerable portion washes into nearby rivers and streams, eventually reaching the Baltic Sea. This influx of nitrogen and phosphorus acts like a superfood for algae, triggering blooms so massive they can be seen from space. Despite efforts to curb this runoff, such as improved fertilizer application techniques and buffer strips along waterways, the problem persists. In Sweden and Poland alone, agricultural activities are responsible for nearly 50% of the nutrient load entering the sea. This relentless nutrient influx sets off a chain reaction. As billions of algae die and decompose, they consume oxygen, creating anoxic conditions. Environments entirely devoid of oxygen. These low oxygen zones wipe out marine life, devastating local fisheries and ecosystems. Meanwhile, the Baltic Sea remains emblematic of a larger global issue, as seen in places like the Gulf of Mexico, where similar agricultural practices wreak havoc on marine environments. Untreated or partially treated sewage from urban areas is a significant contributor to the Baltic Sea's worsening condition. This sewage is rich in nutrients like nitrogen and phosphorus, as well as organic matter that exacerbates eutrophication, a process that leads to an overgrowth of algae. These algal blooms ultimately consume the oxygen necessary for marine life to thrive. In the Baltic region, cities and towns have made strides in wastewater treatment, yet challenges persist. For instance, Poland, which borders the Baltic, has made substantial investments to upgrade its wastewater plants. However, many facilities still struggle to meet EU standards. This is not just a Polish issue. Other Baltic nations experience similar setbacks, with infrastructure aging and funding limited. The untreated sewage problem doesn't just originate on land, it also comes from increased tourism and maritime activities, leading to more wastewater discharge. While efforts like the Helsinki Commission's Baltic Sea Action Plan aim to reduce nutrient inputs by 21, the reality is that progress has been sluggish. Thus, despite improvements, untreated sewage continues to fuel the eutrophication crisis in the Baltic Sea, a silent but deadly reminder of the ongoing environmental neglect. Climate change is now a catalyst, further intensifying the crisis in the Baltic Sea. Warmer waters, a direct result of climate change, absorb significantly less oxygen, compounding the existing problem of oxygen depletion. For instance, when average sea temperatures rise 1 degree Celsius, the solubility of oxygen in water drops by approximately 2%. This is crucial because it means that the sea cannot hold as much oxygen as it used to, making it harder for marine life to survive. In tandem, elevated temperatures speed up the metabolism of marine organisms, leading them to consume more oxygen just as its availability is diminishing. This creates a vicious cycle. Algae and microorganisms thrive, die, and decompose rapidly, further depleting oxygen levels. Duncan Wilson, a marine ecologist, notes that these processes are akin to turning up the heat on a pressure cooker already full of nutrients from fertilizers and sewage. The unfortunate consequence is a cascade of events that magnify hypoxic conditions, stretching dead zones even wider. This isn't just a localized issue, it's mirrored globally in over 700 other dead zones, reshaping the fabric of marine ecosystems everywhere. Across the globe, our oceans are under siege from an expanding network of over 100 documented dead zones. These areas, deprived of oxygen, are silent testimonies to the creeping crisis threatening marine life and coastal economies. Take the Gulf of Mexico, for example, where one of the largest dead zones worldwide spans over 1,000 square miles, roughly the size of Connecticut. Each year, this area suffers from hypoxia, a condition where oxygen levels are so low that marine life cannot survive. The primary culprits? Fertilizer runoff from the Mississippi River Basin and untreated urban sewage. In the South China Sea, similar stories unfold. Industrial waste and agricultural runoff have spawned dead zones that disrupt local fisheries and threaten biodiversity. Here, massive algal blooms deplete oxygen, suffocating aquatic life and compromising food security for millions dependent on these waters. Despite regional efforts to mitigate these impacts, like reducing nitrogen and phosphorus loading, the global picture remains dire. Climate change exacerbates the situation, with warming oceans reducing their natural ability to absorb oxygen. While temporary relief can come from saltwater inflows, such as those occasionally seen from the North Sea into the Baltic, these are mere band-aids. The reality demands radical, coordinated action to tackle this invisible catastrophe before it's too late. Once in a while, nature provides a brief respite for the Baltic Sea. Saltwater inflows from the North Sea occasionally sweep into the Baltic, injecting much-needed oxygen into its depths. In December 2014, for instance, a significant inflow brought about 200 cubic kilometers of oxygen-rich water, reviving patches of this ailing ecosystem for a short period. While these inflows can temporarily alleviate the suffocating conditions, they are notoriously unpredictable and offer no long-term solution. These events are driven by complex meteorological conditions that are becoming less frequent due to climate change, reducing their potential as a reliable fix. Moreover, the relief they provide is fleeting. Within a few months, the oxygen levels can plummet again as the persistent pressures of agricultural runoff and climate change continue unabated. It's like using a Band-Aid on a deep wound. It covers the problem momentarily, but doesn't address the underlying issues. Instead, experts argue for more sustainable approaches, such as reducing nutrient loads from fertilizers and sewage, which would curtail the growth of algal blooms. Otherwise, these temporary bursts of relief will remain just that, temporary. The fight against the expanding dead zones in the Baltic Sea requires bold and coordinated action. Reducing nutrient inputs, namely nitrogen and phosphorus, is crucial. Denmark, for example, has reduced agricultural runoff by nearly 50% over the past 3 decades, highlighting the impact that strict regulations can have. However, the challenge extends beyond borders. It demands international cooperation. Innovative technologies offer another avenue. Oxygenation systems, which inject oxygen directly into water, have shown promise in controlled tests. The city of Stockholm has implemented a pilot project with such a system, reporting localized improvements in water quality. Yet, these are not long-term solutions. The real progress hinges on significant shifts in agricultural practices, wastewater treatment, and urban planning. Public awareness plays a vital role too. When individuals understand the stark consequences of their everyday actions, such as excessive fertilizer use or improper waste disposal, they can drive demand for policy changes. Globally, with over 700 dead zones from the Gulf of Mexico to the South China Sea, radical solutions must be embraced. We must tackle this invisible catastrophe with unprecedented urgency and innovation. The future of our oceans depends on it. The Baltic Sea exemplifies a global crisis, where nutrient-rich fertilizer runoff from agriculture and untreated sewage fuel rampant algal blooms, depleting oxygen levels. In 2022, such blooms expanded dead zones by over 60,000 square kilometers. Meanwhile, climate change intensifies warming waters, further reducing oxygen absorption. Despite measures like the Helsinki Commission's efforts since 1974, dead zones persist. Globally, more than 700 dead zones, including the vast 6,000 square mile Gulf of Mexico region, underscore the urgency. Temporary saltwater inflows from the North Sea offer brief respite, but innovative, sustainable solutions are vital for long-term recovery. The Baltic Sea's dead zone exemplifies a global crisis, affecting over 700 similar areas worldwide. The Gulf of Mexico's dead zone, spanning up to 6,000 square miles, mirrors this environmental dilemma. Agricultural runoff, untreated sewage, and a warming climate create a deadly trifecta, fostering eutrophication and oxygen-starved waters. While North Sea saltwater inflows can offer temporary respite, they often fall short. Radically reducing fertilizer use and enhancing wastewater treatment could make a difference. Yet addressing climate change remains pivotal in reversing this overlooked catastrophe and preserving marine life for future generations. Though the Baltic Sea's plight may seem distant, our actions can spark change. Embrace sustainable farming to cut fertilizer runoff, champion wastewater treatment upgrades, and participate in local conservation initiatives. Globally, push for stricter emissions regulations to combat climate change. In Denmark, for example, farmers reduced nitrogen runoff by 40% through innovative practices. By reducing our own carbon footprint and advocating for systemic solutions, we can turn the tide on ocean dead zones. The Baltic Sea's dead zones are a stark reminder that ignoring our ocean's health imperils our future. With over 7 dead zones globally, radical solutions are essential. Reducing agricultural runoff and improving sewage treatment are crucial steps. Learning from places like the Gulf of Mexico, regions must innovate. Perhaps large-scale bioreactor installations or artificial wetlands could reclaim some areas. Addressing this invisible catastrophe ensures our oceans thrive for generations to come.